This is Module 2, Topic 1, and we're in Lesson 1, Running Circles Around Geometry. So we're going to be using circles to make conjectures. Alright, so for the warm-up here, you'll see that there are 4 objects, and then we're supposed to describe each one. So a point is just a location in space, and we represent it with a dot, and we name it with a capital letter. A line extends indefinitely in opposite directions, and we name it with 2 points. So for example, let's say you have X, Y, and Z as points on that line. You can call the line X, Y, or you could have called the line like X, Z, or Y, X, something like that. Just pick 2 points on the line, and that's how you name it, and then put the line with the 2 arrows on top. A line segment is part of a line. It has 2 endpoints, and again, you name a line segment with 2 points, and you use the endpoints to name it. Put the line on top with no arrows, and then a circle is a set of all points that are the same distance from a center point, and you name it by the center. So you would call this circle O. All right, our learning goals for today, or for this lesson. And here are the key terms. And our essential question is, how can you use what you know about circles to make conjectures about line and angle relationships? Activity 1.1, circles and bisectors. So we're going to use a compass to construct a circle in the space provided, and then we'll label that O. So let me start from the beginning of this. So you're going to use your compass to construct a circle. And we're going to put that center point at O. Okay. Use the definitions. So here are the definitions, and there's a bunch, to complete the construction and answer each question. Construct the diameter of the circle labeled the points D and M. So we are going to construct the diameter, and as you can see here, that's what a diameter is and what it looks like. There are your endpoints. Okay. How many central angles and arcs are produced by drawing a diameter, and what are their measures? So here's a central angle definition. And then here are the definitions for major arc and minor arc. So this would be minor arc. Well, we need the major arc, sorry. All right, so the major arc is ACB, ACB, and then the minor arc is AB. A minor arc is going to be less than 180 degrees. A major arc will be greater than 180 degrees. So, looking here, we've created 2 arcs, 2 central angles. So here's the center, and then this central angle that we've created is 180 degrees. So from here, you can see that it goes 180 degrees. So we created 2 180 degree central angles, one here, and then 2 180 degree arcs, one here, and one here. What name is given to each half of the circle created by the diameter? So each half of a circle is called a semicircle, and I put two names of that. Okay, so there's no letter P or B yet, but I'm going to do number 3, and then that's how I will have named the semicircle. So construct a perpendicular bisector of the circle's diameter, P and B. So to construct a perpendicular bisector, you're going to use your compass because it said to construct. We're going to construct a circle around point D. Make sure that D is the center of that circle and that the circle goes beyond point O. It needs to go past the halfway point. We're going to duplicate that circle. So with your compass, you're going to draw another circle around point M. Okay, so that's how that should be looking. Just making sure everything's lined up. All right, and once you have your two circles drawn around M and D, you're going to connect where those two circles intersect. Okay. All right, so that line is a perpendicular bisector of BD, and we're calling that PM. So I'm just going to erase the rest of it that we don't need, since it's supposed to be a diameter. And as you can see here, that semicircle from 2C, we're going to call this semicircle DPM right there. And then, oh, that's supposed to be a B, sorry. All right, MBD, right there. All right, number 4, use the definitions to identify the circle parts and answer each question. So again, the definitions are here and then over here and up. Identify all the drawn radii of the circle created by the diameter and its perpendicular bisector. So radii, that would just be more than one radius. So when we created this perpendicular bisector, it created 1, 2, 3, 4 radii. OD, OB, OM, OP. So I wrote those here. And they're all segments. Part B of number 4. What central angles and arcs are produced by the diameter and its perpendicular bisector? So central angles, I made a list of all the central angles. So let's take a look. We have this central angle here, POD. So that's a central angle. DOB, that's another central angle. BOM, that's another central angle. MOP, that's another central angle. And all of them equal 90 degrees. So this is 90, this is 90, this is 90, this is 90. So there you go. And then the arcs, each arc that I wrote goes with the central angle. So for MOB, that central angle goes with the arc MB. So we have arc MB, we have arc PM or MP, PD, DB. So I wrote all of those down. And each arc, again, is 90 degrees. So if the measure of angle MOB is 90 degrees, the measure of arc MB is also 90 degrees. Okay? Draw a line through two of your labeled points on the circle to form a secant and a chord that's not a diameter. So for secant and chord, you can see over here, these are the definitions. A secant looks like this, a chord looks like this. They both look the same. The only difference is that a secant will extend out of the circle, whereas a chord is limited to the circle. The endpoints of a chord are on the circle. Okay, so let's draw that. So here's my secant. And here's a chord. So notice that this creates a triangle here. It also creates a triangle like this. All right, use a protractor to measure the angles and the triangle and a ruler to measure the sides. So let me see. So I'm using this triangle here. So if I measure these two angles, each of those is 45 degrees. And then if I measure these two sides, they're equal to each other. So this will be 45 degrees, and 90 degrees. And these two angles, these two sides are congruent to each other. So I represented that here and here. And we can clearly see that this would be an isosceles right triangle. It would also be the same this way. The angles would be the same. So it would still be an isosceles right triangle. Obviously, this length and this length would be the same, although they would be different than these two lengths. But it's still an isosceles right triangle. Number 6, compare your circle diagram with your classmates. Did everyone create the same triangle? If you guys obviously did this on your own, you would have created different triangles. So, yeah. And then part B, are the circles similar? Yeah, all circles are similar, but not congruent. So similar just means same shape, different size. So if you have a circle this size and this size, they're similar because they're the same shape, but they're different sizes. They're not congruent because obviously one is bigger than the other. All right, what conjecture can you make about this type of triangle? Isosceles right triangles are always similar, but not congruent. So an isosceles right triangle is always going to be 45 degrees, 90. So 45 degrees, 90. And it doesn't matter how big or small you make it, it's still the same angle measures. All right, activity 1.2. Let's use your geometric knowledge to make a few more conjectures. Consider the circle and triangle that Josh constructed. Okay, so real quick, I just wanted to define vertical angles. That would be the angles that are opposite each other when two lines intersect. So this angle and this angle are vertical angles. Even though they're not vertical from each other, they're just opposite each other. So vertical angles are just opposite angles when two lines intersect. Angle POM and DOB, so that's POM, that's DOB, are vertical angles, and BOM and POD are vertical angles. All right, Faith and Trey each make a conjecture about the measures of vertical angles. Consider their conjectures and determine who's correct. Faith says all vertical angles are congruent and they measure 90 degrees. Trey just says that they're all congruent. Trey is more correct because all vertical angles are not 90 degrees. So these two are clearly not right angles, but they are still vertical angles. All right, consider the central angles MOP and POD. I just went ahead and copied the circle from up here, down here. All right, what do you notice about the sum? So MOP is this angle, and POD POD is this angle. If I add these two angles together, it makes a line. So that's 180 degrees. What can you conjecture about the sum of these two arcs? MP plus PD, again, if I add them up, it equals 180 degrees because it's a semicircle. All right, you can see over here, this would be the definition of a linear pair. All right, construct EL through the center of circle parallel to PM. So, get rid of all of that. Okay, so we're going to construct a parallel line to this line. So we want to make a parallel line to this line that goes through the center, but we're going to construct it, so we're going to do it right. So the first thing I want to do is draw an arc around point P, making sure it is centered. I'm going to duplicate that circle, and I'm going to draw that around the point that I'm trying to go through. All right, the next thing I want to do is get the distance from, do I need purple? No, I do not. Okay, the next thing I want to do is get the distance from here to here. And I want to duplicate that distance there. And then it should create an intersection here. And I want to draw this line from O through that point. Okay. All right, and voila. Just created a parallel line. Okay, and of course you would do that with your compass. We have done it before. This isn't new. All right, so angle PMO, which is this angle here, and EOD, I forgot to label my sides here. So from here, L. And so EOD is that angle there. And when we add them together, not add them together, I'm sorry, the relationship between them is that they're equal to each other. So this angle and this angle are congruent. And then let's take a look at MPO. So angle MPO, that's that angle here. POE, POE. That's this angle here. Those two angles are also congruent to each other. Make a conjecture about another angle pair you know something about. This angle here and this angle here, if you add them together, they will give you 90 degrees. And they're also equal to each other. So this angle and this angle are equal to each other, which we knew from before. So this is 45 degrees. That's 45 degrees. All right, so we could say that we could add them to equal 90, but they also are just 45 degrees. So they both equal each other, and they're both 45 degrees.